So what I'm going to do in this video is introduce a different method from the one that is commonly taught. A different method to find the inverse of a function. So, here we go. The method I want to discuss is something that I call the fx transform. The reason why we call it fx transform is that in the course of finding the inverse of a function, what we do is that we transform the function f of x, sorry, not the function, the variable f of x to the variable x, and the variable x is transformed to the variable f inverse of x, f minus 1x. One slight alteration we make in the working is that we use a substitution so that the transform itself is written as f to x to big F. So like this, it might be easier to remember for most people. So you have common f, which is the function itself, x, which is the variable x, and big F, which is the same as f minus 1x. So what I'm going to do now is work 4 examples of varying difficulty so that you can see the application of the transform, and you can see that this method is actually a valid and viable method. So, rubbing off the board here now. Right? Alright, so the first example we want to use is the function f of x is equal to x plus 1. Suppose we have that question and they tell us to find the inverse of that function. So what do? Your step 1 would be to let f minus 1 of x, which is the inverse that they're trying to find, be equal to big F. After we do that, the second step would be, in the first instance, to change f of x to x, and also to change x to big F. Alright? Remember the form of the transform. Small f, x to big F. Alright, that's what we have there. So I'm going to rub off these two now. And when we apply the transform, what we actually will be doing is transforming this equation to the following equation. So what we will have now would be that x is equal to big F plus 1. And then your third step would simply be to solve for big F. Right? When we solve for big F, what you'll get would be that we take the plus 1 and we carry it across. So x minus 1 is equal to big F. Therefore, big F is equal to x minus 1, which is to say then, therefore, f minus 1 of x. Sorry, I'll just rub this off. So this is what we have here. So we rub off on top here now. We'll just have that f minus 1 as the last step will be equal to x minus 1. Example number 2. Next function we're going to do is a function f of x is equal to 3x minus 7. And we're going to use this same method to find the inverse of that function. So we start off f of x equal 3x minus 7. Again, the first step is to let f minus 1 of x, which is what we're trying to find, be big F. So the second step would be to change. The second step, step 2, is where you actually invoke the transform. Change f of x to x, and then you change x to big F, and then after you do that, you have a new equation which would now be that x, you change f of x to x, so x will be 3 by big F, you change the x to big F minus 7. The next step will then be to solve for big F. So we're solving for big F now. Alright, step 3, solve for big F. So we had the equation. The equation was that x equal 3 big F minus 7. So we take the 7 across, minus 7, sorry. X plus 7 is equal to 3 big F. So x plus 7 over 3 is equal to big F. And then switch the variables, switch the sides. F big F is equal to x plus 7 over 3. And therefore, okay, I'll just write it over here now. Therefore, f minus 1 of x is equal to x plus 7 over 3. And that is it. Example 3. Example 3, I'm going to change the lettering now, because one of the problems that people have with this subject of functions is that they work 100 problems with the letter F. And as soon as they change F to G, or to H, or to K, or to L, M, N, O, P, or any other letter, suddenly they don't understand and they don't know what to do. Right? So instead of F of X, we're going to say E, F, G, G of X. G of X is a commonly used one. So let us say, for example, that G of X is equal to F of X plus 5 over X. And they want us to find the inverse G minus 1X. G minus 1X, of course, would be that. So in this case, the Fx transform will be written as G, X, big G. Small g to X to big G. Same thing as the F. The only difference is that we change the F to G. So following that template, the steps will proceed as follows. Step 1, you let G minus 1 of X equal big G. Step 2, you change G of X to X, and you change X to big G. Well, change small g, sorry, right? Small g, same thing. Right? So you change small g to X, and you change X to big G. And we have a new equation. So we're rubbing up this part in the center here now. So we're saying that X is equal to 4 by big G plus 5 over big G. And step 3 now would just simply be to solve for big G. Yes? So at this point, it's just straightforward algebra going down the road. So you're rubbing off again. X equals 4 big G plus 5 over big G. X equals 4 big G plus 5 over big G. So we cross multiply. X by big G is equal to 4 by big G plus 5. And then let's see how we do this now. You need to get all the big G's on one side. So we bring 4G across. So we have X by big G minus 4 by big G is equal to 5. So that big G, factorizing here now, into, I need to go up a little bit to this. So I'll come in on the top here now, so that we're coming back on top with the same equation. Right? X by big G minus 4G is equal to 5. And we can rub off everything else here now. So that big G into X minus 4 is equal to 5. So big G is equal to 5 over X minus 4. And remembering, of course, from the very first line where we had the substitution, G minus 1 of X equals big G, it means therefore that G minus 1 of X will be equal to 5 over X minus 4. And that, ladies and gentlemen, is your solution. So we're going to move on now to the fourth example, where we just increase the difficulty a little bit, but you will see that the procedure is identical. And just as we did for the third example, we're going to change the lettering again. So E, F, G, H. So let us use H. H of X is equal to 3x minus 2 over 2x plus 1. And we are required to find H minus 1 of X. So just as we did in the case of F and in the case of G, we expressed F transform in the case of H as H to X to big H. Common H to X to capital H. So we're rubbing this off now to make room for the writing out of the solution. So in step 1, we say let H minus 1 of X equal big H. In step 2, we say change H of X to X, and you change X to big H. Step 1, step 2. Note, we write now the steps. So we rub this off again now to make more room. So after we execute step 2, what we'll end up with having transformed H of X to X and X to big H would be X is equal to 3 by big H minus 2 over 2 by big H plus 1. The next step, step 3 of course, would be to solve for big H. So this is your step 3 now. Now we're going to execute step 3. So we're rubbing off now, we're rubbing off here. And we're going to write this over at the top so we can make room for the writing to follow. So we cross multiply x into 2h plus 1 equals 3h minus 2. And we multiply this out now, we get we get 2x by big H plus x is equal to 3 by big H minus 2. And now we want all the big H's on one side. So what we're going to do is take the minus 2 across here and make it plus 2. And we're going to take 2xh from the left side and carry it across to make it minus 2xh. So what we have on the left side would be x plus 2 being equal to 3 big H minus 2x by big H, which will lead us now to x plus 2 being equal to big H. We're going to factor out the big H now into 3 minus 2x. Alright, so from here I'm going to go back to the top, rubbing off here, and we say now that, well, let me start over from the top. X plus 2 is equal to H into 3 minus 2x. That's what we're starting with. So you just divide by 3 minus 2x. So x plus 2 over 3 minus 2x will be equal to big H, playing off in the bottom here now. And of course, we're switching sides just to comply with convention. And we have that big H is equal to x plus 2 over 3 minus 2x, which will then imply that h minus 1 of x will be equal to x plus 2 over 3 minus 2x. So that, ladies and gentlemen, is the sum of the matter where it concerns finding the inverse of the type of function that you're likely to find in a CSEC mathematics paper.